So we're on our second video that is dealing with limits of functions. And in this video, we will look at another example and use that example to understand the formal definition of what the limit of a function is. And so in this video, we will focus on this specific function, the function f of x equals x minus 1 in the numerator divided by x squared minus 1. Why is this a good function to look at? Well, there's something very interesting in this function, and that is that in the denominator we have x squared minus 1. X squared minus 1, if we take x equals 1, then x squared minus 1 equals 0. So we have in our denominator 0, which we know is not a defined operation. So we know that we have some kind of problem at x equals 1, which I show right here, where we've shown that the function as it's written is not defined at x equals 1. However, it is defined everywhere else, the positive x-axis. We'll have a similar problem when x equals negative 1. Okay, so what we can do, though, is we can look at what happens as we get close to 1. So we can get close to 1 either from x's that are smaller than 1 or from x's that are larger than 1. And when we look at that, as we approach x equals 1, as we look at f of x, we'll see a very interesting pattern. So in this table here, you'll see we have x's and we have f of x. And I started here both from above and below, so this in this direction, and we're going towards 1, where x equals 1, the function is not defined. So at x equals 2, we have 2 on top. We have 2 minus 1 divide by 4 minus 1, which is just 1/3. And indeed, we show that right here. At 1.5, we get f of x equals 0.4. And as we move down here, closer to x equals 1, we see that the value of f of x is going and getting closer and closer to 0.5 or half. So we see that it's actually behaving in a very consistent way. It goes from 0.4 to 0.43, 0.45, 0.49, 495. So we're getting really close to 0.5, or f of x equals half. But again, at 1, it's undefined. What happens if we look at lower x's? Well, at 0.7, we have 0.58, then 0.55, 0.52, 0.51, 0.507. We finally get very close to 0.5 from below as well. So we see that also from below, f of x gets closer and closer to 0.5. So what we're going to say about this function is that f of x gets closer and closer to 0.5 as x gets closer to the value 1. Okay, and in other words, we're going to say that the limit of f of x as x goes to 1 is 0.5. So in this example, we saw for a specific x where the function is not defined, that we can still have a limit of the function as we get closer to that value of x. Let's define this a little bit more formally. And here you can see a formal definition of the limit. So what it says here is, if we can make the values of f of x arbitrarily close to L, meaning as close as we would like, as x gets closer to a from either side of a, by taking x to be sufficiently close to a but not equal to a, then the limit of f of x as x approaches a equals L. And we write it in two ways. We can write it either as the limit or in this form with arrows. Let's look at this definition a little bit more closely, and let's use our previous example, f of x equals x minus 1 divided by x squared minus 1, where we looked at the limit as x went to 1, and we saw that f of x approached half, or 0.5. So in this case, we're saying, as we make the values of f of x, which is this f of x, arbitrarily close to half. Okay? And when we say arbitrarily, what we mean is that we really could get as close as we want to the value half by taking x as close as we want to a, where a in this case is 1. Then, if we can do this without actually saying x equals 1, but we can get as close as we want to half by taking x as close as we want to 1, then we can say that the limit of this function as x approaches 1 is equal to half. And we write it in this format usually, but we also sometimes write it in this format. And this is the definition, the formal definition of a limit. And what we will do in the next few videos is really look at examples so that you get a good feel for what happens in different types of functions as we look at limits. We will look at limits as x goes to infinity, as it goes to negative infinity, as our f of x goes to infinity. And so you'll get a good feeling for what this limit can be used for and how it is used. So join me in the next video as we look further at the limits of functions.